Hello, welcome back to physics class. This is the third class on simple AC circuit. In the previous videos, we've discussed about what an AC circuit is. We talked about resistance in AC circuit, capacitance in AC circuit, as well as inductors in AC circuit. So let's quickly take a revision on that aspect. We know that from what we said, Ohm's law for resistor in AC circuit V is equal to IR. And for capacitors in AC circuit, our voltage will be equal to I times the capacitive reactance, IXC. Don't forget that XC is equal to 1 by 2 pi FC. And for inductor, our V will be equal to IXL, where our capacitive inductance XL is equal to 2 pi FL. Remember, we also call this as omega L and this as 1 over omega C. So we can equally call this VR, call this VC, and this VL. So take note of that. So as we mentioned in the last video, that we've taken a look at the R and C circuit, R and L circuit, as well as R, L, and C circuit. That is the when we have capacitors and resistors, capacitor and resistor in series, and as well as inductor resistor in series, and then the three of them in series circuit. So let's quickly take a look at the series circuit of this system. When we have capacitor, okay, let's go with the first one, R and C series circuit. What we mean by this is that from our explanation, it is known that both capacitance and resistors offer a form of reactance or resistance to an electrical system. So when we have the two of them in series, what we are expecting to see is something like this. Let's say we have a circuit of an alternating current, such that in this circuit we have a resistor and a capacitor connected in series. You can try to put your ammeter here. Then what happens to this? This is our R and this is C. They are both in series. So what happens in this kind of system? So our main concern here is just to know the total resistance in the system, as well as the total voltage across the system. So the total resistance for this particular system will be known as impedance. That is, our total resistance is called what? Impedance. Impedance. And impedance is given by letter Z. So Z means the total resistance offered by this system. Since there's a resistor and capacitor, we cannot call it resistance again. So because this one has what we call capacitive reactance and this one has what? Just normal resistance. The impedance square will be equal to R square plus XC squared. That is to say, Z square is equal to the square root of resistance square plus capacitive reactance squared. So this is what you have in this system, which transform to the normal formula that says V equal to IR, so that R stands for resistance. For since there is more than one resistance here, resistor descending to resistance and the capacitive reactance, which is known as impedance, we call it IZ. So sorry, this is Z, not Z square. This is just Z, not Z square. Okay, so which can be transformed to as current times the square root of resistance square plus capacitive reactance square. So that is that for resistor and capacitor in series circuit. So without drawing any further diagrams, similarly, we have capacitor and inductance, resistor and inductance in series circuit. We just replace this place with what? An inductor. So R and L series circuit. I'm not going to draw any diagram. We are going to proceed straight to the formulas involved. In this case, our impedance Z square will be equal to R square plus XL square. So which means that impedance Z is equal to the square root of R squared plus XL squared. So don't forget how to evaluate your inductive reactance, which simply implies that potential or voltage will be equal to IZ also, but the Z in this case is square root of R squared plus XL squared. Remember, in this case, XC is equal to 1 over 2 pi FC. And for inductor XL is equals to 1 over 2, inductive reactance is equals to 2 pi FL, straight line equation. So let's take a look at resistor and inductor in series. We have a resistor and inductor in series, I mean inductor and capacitance in series, L and C circuit. L and C series circuit. So we have the inductor and resistor and a capacitor in series circuit. Our impedance Z will be equal to XL minus XC. There's no need for square root, it's just direct subtraction, which simply means that 2 pi F L minus 1 over 2 pi F C. So that is that. And you can play around the formula. Z can be equal to 4 pi square F square LC minus 1 all over 2 pi FC. So any one of the choice. As such, our potential V is equal to IZ also, where Z is XL minus XC. And the major reason why we are here is the R, L, and C, R, C, and L, or R, L, and C, anyone you want to take it, R, L, and C, you can arrange it any way you like, in series circuits. So if you have this circuit, our impedance Z is equal to square root of R squared plus XL minus XC squared. This is the impedance, which simply means that Z square is equal to this. Yeah, it means that Z square is equal to R square plus XL minus XC squared. So this is what you have to know about the impedance, and from there V is equal to IZ also, where your Z simply stands for square root of R square plus XL minus XC squared. So this is what you have about capacitors, resistors, and inductors series circuit. So stay tuned. In the next video, we'll be talking about resonance, power, and some other things in AC circuit. Thank you.